Yeah. Okay. Thank you for your patience. So you do know, right? What are label encoding? What is ordinal encoding? What is one-hot encoding? What is one-hot encoding? When will we go for one-hot encoding?
Convert a numerical and non-numerical to numeric data.
Okay.
When we have categorical nominal data.
Categorical nominal data. Yes. And what about the ordinal encoding? Have you ever heard of ordinal encoding?
We do that label encoding, no? For that.
Yeah. When you have an order when it comes to the input variable, let's say, let's come to the size of the t-shirt. Small, medium, large, double XL, XL, it has some order. See, if you do the same one-hot encoding for order data, it won't represent completely. So when you have an order in nominal data, you are supposed to go for one-hot encoding. Sorry, ordinal encoding. Understood? See, label encoding itself saying, right, it's supposed to be for label. So it is for output. See, label encoding doesn't represent ordinal data. Whenever we are having the classification problem, in that we'll be having output, right? So for that output, we'll be applying the label encoding. Okay. Do you understand what is the difference between ordinal and label? Hello? Please confirm.
Can you repeat, please? Can you repeat, please?
Just a minute. Let me share the screen. Fantastic. Okay. Okay. Yeah. Can't share your screen, right? Just a minute, guys. Enter screen. Yeah. Can you able to see my screen?
Yes.
Yeah. No. Okay, I'll show you with the code itself. Are you able to see my screen? Hello?
Yes. Yes, we can
Yeah.
see it.
Let's see. Let's take a sample data that I have taken from the Kaggle. Here we have age, column, gender column. These are features. And we have output column as COVID. We have to determine, we have to predict whether whatever the inputs we will be having. Based on that, we should predict whether you have a COVID or not. So here, can you tell me what are the data types we will be having? We have in this input variables. What type of input variables will be having?
Age, integer.
Age, integer, fever,
Gender.
float.
Gender.
Okay. Gender is what kind of data type it is?
Categorical.
Categorical, but it is nominal, right?
Nominal.
Nominal.
Yeah. What about the cough?
Float.
Cough.
Ordinal data.
Okay. Cough. Okay.
Yeah.
That's
See,
what
we have mild and strong, so it is an ordinal data.
Ordinal data.
Yeah. What about the city?
it's nominal.
Nominal.
It is nominal. What about the has COVID?
It's also nominal.
Binary
It is
data.
also yeah.
Binary data.
It is also nominal, but we'll be using this as an output.
Okay.
So it is
Binary.
it is labeled.
Label.
Yeah, it is nominal, but we are using for output. Let's say I have two categories. I have in cough, I have two categories. One is mild, one is strong. See, if you just label encode this, it randomly gives values to mild and strong. But we want to give priority based on the order. See, if it is giving strong 0 and mild is 1, then I mean the intuition is completely different, right?
Yeah.
So we have to give priority to strong.
Strong.
If you are having the mild symptoms, in that case you might not have COVID. When you have a strong symptoms, there is a higher possibility that we might have a COVID, right? So we are supposed to give higher priority to strong. Understood?
Yes.
Yeah. So when we do, when we go for model building, we are supposed to do the encoding according to different categorical data we will be having. Right? So for age, if you have any missing values, do we have any missing values?
No. Zero.
Yeah, we don't have any missing values. For gender, we don't have any missing values, but it is in a nominal data. What we are supposed to do, we have to do one-hot encoding, right?
Yes.
Yeah, are you guys following? When it comes
Yes,
to
sir.
fever, when it comes to fever, we have 10 NA values. Those are null values. What we are supposed to do when we have null values or
Imputation.
NA values? Yeah, you are supposed to go for imputation. What are the imputation techniques we'll be having?
Mean, median, mode.
Yeah, mean, median, mode. You can go with, in this case, fever, which imputation techniques you will go for?
Mean.
So
Mean.
mode.
Yeah, we can go with
Mode.
mean. Absolutely, you can go with mean.
We-
And when comes to cold, do we have any null values?
No. Zero.
No. And city, we don't have
Zero.
it. Yeah. So when we do the model building, we have to convert this nominal data. You have to convert this encode. I mean, convert means encode. You have to convert the cough data. You have to convert the city data, and you have to also convert the COVID. Which transformation you will be using for gender encoding? Normally, when you work on model, which encoding you will go for?
One-hot.
Gender.
One.
You will,
One-hot.
obviously you will be going for one-hot encoding. What about the cough?
Label encoding.
Label.
Label encoding. See, label encoding can do the job, but I recommend you to go for ordinal encoding. Ordinal encoding gives high priority. See, in ordinal encoding, you can manually can give like strong as a 1, mild is a 0. So it will give a priority to that severity. See, here we have just two. If you have multiple, like small, medium, large, extra large, in that case, if you go for label encoding, it will randomly gives the number. It will randomly gives the number. Instead of that, you can simply mention whichever the category is priority. You can do using the ordinal encoding. That just do some research about the ordinal encoding in SQL and documentary. You'll find why we are using the ordinal encoding. And when it comes to city, it is also nominal data. For this, which encoding you will go for?
Label encoding.
One hot.
No, you won't go for label encoding. You have to go for one hot encoding.
One hot encoding.
Yeah. For this COVID, you can go with one hot encoding as well as you can go with global encoding. Anyway, it has just to say whether you have a COVID or not. If you have a COVID, it will say 1. If you don't have a COVID, it will say
0.
Okay.
In city, you said just now that we can use the label encoding and
See,
hot encoding.
No, only one hot encoding you'll be using.
Why, sir? It will give us 0 and 1s, but in label encoding it will give us.
See, let me explain this way. See, if you are giving some random values,
Yes.
so you won't be able to figure it out what is what. If you are going for the one hot encoding, it will. I'm not able to write on screen actually. I don't know why. So if you are some giving random values to that particular city, you won't be able to figure out what it is. If you are giving going for one hot encoding, you can easily figure it out which city you are talking about.
How we are going to mention it? And not encoding, it gives a 0 and 1. If suppose Bangalore is 0, Delhi is 1. What about the Calcutta? And
no, we have 3. We have more than 2, right? So if so, let's say it is giving Bangalore is equal to 0, 0, 1. It will give Delhi 0, 1, 0. It will give Bangalore 1, 0, 0. So something like that. It will encode when it comes to one hot encoding. So you can easily figure it out what it is talking about. But when it comes to
but if we have like 100, 200 cities, then what? Like in cities, suppose we have Bangalore, like 100 cities, different cities are there.
Yeah. This is the one thing actually. You have to go with one hot encoding only. See, if you have 100 and 120 cities, if you simply do the label encoding, will you able to figure it out? Will you able to differentiate between those numbers 1 to 100? You won't be able to do that. But when it comes to one hot encoding, you can easily differentiate. That one thing you should keep in mind. Got it? So when you are going for the model building, you have to do it every single time. Every single time you have to do it for every single column. Then you have to concatenate. That we'll see. We are checking whether we have any null values or not. So before that, I am importing the simple imputer, one hot encoder, and ordinal encoder. I am using the one hot encoding for gender, one hot encoding for city, and one hot encoding for COVID. Or you can simply what it is called. You can simply convert. You don't need to convert or encode this. You can simply mention no is equal to 0 and s is equal to 1. It will simply take those values. You don't need to go for any one hot encoding or label encoding when it comes to when you have just 2. Then I'm importing the one hot encoding, one hot encoder, ordinal encoder, and simple imputer. What simple imputers do? It is a simple imputer. It simply replaces the whatever the NA values are there with me. Okay.
Sir, what is the 10 in df dot head of 10 parameter?
Which one? This? Yeah, I'm taking the first 10 of entries of that particular data frame, and from that I'm taking just 5 samples, so that sample will come out.
Random samples.
Random values will come out. so that I can easily figure out how many unique values I can have. You can keep running. It will give you random samples from that top 10 samples, or you can simply remove. No issues. Top 10 values will be entered. Okay, so here we have mild and strong. This thing you should remember, when you have order, better go for ordinal encoding. When the name itself saying you should go for ordinal encoding when you have order in your nominal data, why not? And when it comes to label encoding, why we see in supervised learning, what is the definition of supervised learning? Can any one of you?
It is a labeled data. We can say.
Labeled data, right? When we have a label encoding that is especially built for label, then why we are not going for label encoding for label data? That you can figure it out. Just go to a scikit-learn documentary, read it, you'll get it. Okay, the whatever the values we'll be having, I'm just splitting into 10 rest. Yeah. So I'm just So I'm just the normal procedure that you have that you people go through when you are building the model. First, you will take some column like first what we are doing, gender one-hot encoding will be done. First, you will take gender, and then you will do one-hot encoding. Then you will take cough. Then you do ordinal encoding. Then you will take city. Then you will do one-hot encoding. Like that, you will be doing every single thing like differently. Then you will add all those things using the concatenation function. See, these are all encoding, and then you will add all those into one data frame. That is this. It is a NumPy array. Why we are using NumPy array? It is a bit faster compared to the normal list. Yeah. So we'll be using the NumPy array. Better you guys use NumPy array. It will be faster, and as well as it will take less memory. When it comes to computations, this NumPy array is very fast. And yeah, this is the whole transformer data set. What I'm doing here, I'm adding the all whatever the encoding have done. All I'm concatenating all the things like gender, train, cough. Now the data set become 80, that is for train, and 7 columns will be having. So whatever the gender will be having, see, you might have known the this idea, right? Let's say I have one-hot encoded the gender, but by just keeping one column, you will be able to know which is what, right?
Yes.
You have you have an idea about that, right?
Yes.
In order to avoid the sparse matrix,
Yes.
or in order to avoid the more memory. When you have 4 categories, like we'll have let me see, here we have mild and strong, and we have done the ordinal encoding.
You said that we can define the values for the ordinal data, but where have we defined that?
Yeah, I'll show you. I'll show you that. Here it is. I'm giving preference to strong first and then mild. It will give you 0 for this and 1 for this.
So it is sequence wise, like
it is sequence as when it comes to ordinal.
if it is very strong, then it will give 2. If we put it after strong.
Yeah, you can add. Yes, this is exactly what ordinal encoding. If you want more information, you can go to a scikit-learn documentary. You can read those. Yeah, once it is done, see, I've just take once it is done. Okay. Yeah, this is the final matrix. Once you concatenate all these things, we'll be having 80 for train data. I'm just splitting into train and test, we don't have that much time. We have to complete whole the thing in half an hour. So it is hard to go through all those things. But once you complete the whole transformation, and you have to concatenate all those things like age, fever will be having two, right? It is numerical data. We have done imputation. We have done imputation as well. Let me show you that too. See, here I am doing the simple imputer. For which one? The fever. Fever will be having some NA values, right? Those will be replaced with what? Mean. And then I am doing the one-hot encoding for gender and city. That you can find. This is the NumPy array for one-hot encoded gender and city. And when it comes to this is for gender. Okay, we'll be taking the output like the label and dropping the all input variables. AD, this is train data, and test data will be 20.1. We'll concatenate all, and we'll be getting 80 entries, and we'll be having 7 columns. Once we transform and once we concatenate all those encoded values. But instead of going for each and everything, you can simply use this column transformer and you can do it. Do some research about the column transformer. Go to scikit-learn documentary. You'll find all the details of the column transformer. It will make very easy. You don't need to write one and you don't need to go for each and everything like simple imputer, ordinal encoding. Like individually, we don't need to do. You can simply create one variable that is transformer. In that, it is a function actually. It is a library we'll be having in scikit-learn. You can simply import that library, and whatever the imputation you want to do. The simple imputer, it is a function. Ordinal encoder, it is also function. One-hot encoder, it is also function. You can simply put all those in just one list, and you can print. See, this is the exact output we got in doing individually and all at once. Got it? Hello?
Yes, we got it.
Yeah, this is, see, it makes things very easy. It makes things very easy. Next time when you are going for model building and all, just use this column transformer instead of going for individual encoding techniques. You can do the simple imputation. You can do mode imputations also. You can do. Have any doubts? Just let me know.
We are doing it after train and test split, no?
Yeah. You can do previously only. Just I'm showing how train and test is looking like. But you can do previous to that too.
In this step only, we need to mention the parameters also, like strategy or
Here itself you can mention. See, whatever the columns that you are doing that particular imputation, that you have to mention. And other than that, so if you don't want to mention any other column, you can simply say pass through. It will skip those. Or if you want to delete other than that, you can simply say delete or drop.
we have only given the column names, not the table.
Yeah, column names only. So based on that only, right? For simple imputation, where we are doing for fever only, right? So in fever only, we'll be having the NA values. So we are doing the imputation. Simple imputation means mean imputation will be replacing all the NA values with mean.
No need to mention the table name,
Table name?
like which
Okay,
table.
data frame you're talking about.
Yes, yes.
Yeah, no need. Any doubts? Sorry guys, I couldn't able to see those comments. Just let me see. Okay. Yeah, sparse means, okay, sparse means if you have so many number of zeros and ones, it will create a kind of sparse matrix. We'll do n-1 columns, right? Yeah, when it comes to, see, if you have gender column, that is male and female, and you have given male as a 0 and female as 1. Even though you don't have that one column, I mean female column, you can simply say wherever there is a 0, it is a male, and if there is no nothing, you can say simply it is female. Just by looking one column, you can easily figure it out other, right? If you have just 2, and if you have 3, just by looking at 2 columns, you can figure out the third one, right? I hope you understand.
Okay, sir.
Yeah. That's just a name for transformation. That's it.
Even we can use effect coding scheme also, no, sir?
Sorry?
Effect coding scheme.
Coding scheme.
Yeah.
I didn't understand. What?
Effect coding scheme. Effect coding scheme.
I don't know.
That also comes under this encoding only, like one out encoding labeling after that.
Effective what?
Effect coding scheme.
Effective coding. I'm not aware of that. I'll try to do research on that. Effective coding. Okay.
I have one doubt. If we do like a normal doubt, if we do that n-1 encoding, no? So in that case, the last one will get like delete, no, from our data set.
Yeah, it won't. Yeah, it will be deleted. I mean, the memory won't be allocated for that.
Then it won't affect our model.
It won't affect it. Still, it is representing the same rank.
But it is not in our data set. No? Like we build model and it is not even on model. Like while prediction, suppose we are inputting these things. So will it do prediction related to that? That is that.
I don't think so. I don't think it will give. Just use this whenever. Just do some research. Just go. What are the new terms that you came across here?
Okay. Thank you.
Have you come across any new names, new terms?
Frequency encoding.
Frequency encoding. No, I'm talking about the present. I mean this.
Okay.
Ordinal encoder.
Ordinal encoder one. Column transformer. Just do like brief research about it. Go to the sklearn documentary. You'll find everything. Even though you have like 5 years of data science knowledge, you won't be able to know all those things. Just simply go to sklearn, and there are so many updates coming every now and then. Be updated. Just go to the sklearn, and you can watch all this documentary. You'll you will be updated with according to the technology. Just go to the sklearn directory. That is the only source. Other than that, just don't go for it. Yes, just go to the sklearn. Whatever the word that you are coming across, go to sklearn direct documentary, and there you will find everything, even with code. Show your system means. What do you mean by that, Vishwajit?
Sir, what is the primary purpose of this column transformer?
That is what I'm explaining, right? See, when you are doing the label encoding in a one hot encoding, simple imputation individually, it will take a lot of time. It will take a lot of time. Instead of that, you can simply build one. Just, I'll show you.
Okay. Just to save time.
Yeah, there is so much time. See, here we have just 3 to 4 columns. If you have like 20 to 25 columns, will you do all those things like one by one, one by one, one by one? You won't be able to do that, right?
Good evening,
Okay,
everyone.
sir.
Yeah, it will take a lot of time, So in order to avoid that, we'll be using this column transform. Okay, guys, this is all about column transformer. Just do a brief research about it and try to apply while you are doing model building. And yeah, that is it. That is all. If you have any doubts, you can do in message in the comment section. Or else we'll wrap up this session. And thank you for joining. Have a nice day, and we'll see you in the next session. Yeah, you're welcome, guys.